So that was a great talk about monitoring. I need to go back home today and fix everything. And also you didn't say Kubernetes once, and that was great. So there's probably something wrong with the microphone. Yeah. So me as well, I'm not going to talk about Kubernetes today. I want to tell you about the time when I was a child. When I was a kid, I really liked programming and creating computer games. I would think of cool ideas for games and program them and tweak them and play them. And from time to time, I would make a computer game that I thought was fun, and I wanted to share it with friends. I would copy it onto a floppy disk and ride my bike to a friend's house, and we would plug it into his computer, play it, and even tweak it while we play it, so it will be much fun. And what I really liked back then is that I could build something myself and share it with friends and see them enjoy it. So today, that's mostly what excites me still. Building things and seeing users use my software. However, I have more responsibilities today. I have to make sure that the software that I make is up and running at all times, and that more and more users have access to it. And that's why serverless is such a great idea, and I'm excited about it. Because it allows me to focus more on building the software rather than on operating it. So today I'd like to tell you a bit about how we use serverless at the startup I work at, and let's get started. My name is Tal, I'm the co-founder and CTO of Torii. Torii is a SaaS management platform. So it basically means that we help your IT teams control and manage all of the SaaS software that you use daily. What's more interesting is we built our solution entirely on serverless. So we don't have even a single server to SSH into. And before I dive into serverless, I thought we'll do something fun together. So let's try and build a Slack bot in less than 1 minute. So it's going to be a very simple Slack bot. I call it the upper bot. And as you can see, it's a simple Node.js Express application that gets a text from the user, it uppercases it, and it sends it back. Pretty simple. Now I want to deploy it to the cloud. And I'm going to use a tool that is called Up. It's a very simple tool. I'm going to teach every one of you how to use it. You have to write Up and then click the return key. And after you do that, it takes a few seconds, but Up will take care of all the deployment. And in the end, you'll get an endpoint that you can make requests to. So let's see if it actually worked. So we'll curl into it with some random text. And yes, it works. The text came back with an uppercase. OK, so now let's plug it into Slack so everyone can use it. Slack has a / command feature where every time someone will write uppercase, a request will be sent to this endpoint. So after we configure it, that's how it's going to look like. Someone will write uppercase and any sentence that he'd like to have. And yeah, it works on my machine. So yeah, so that's great. And what just happened here? So we wrote some code, very simple, and we deployed it with 0 effort. And we got a Slack bot up and running in less than a minute. Behind the scenes, Up did 2 main things. It deployed 2 entities to the cloud. It took our code, wrapped it into a Lambda function that is now available to accept requests for uppercasing words. It connected it to an API gateway that is responsible to get requests from the network and forward them to the AWS Lambda. So that's basically our serverless application up in the cloud. So what did we actually get here? So we got a highly available Slack bot. So there's no servers, and they're not going down for this one. It scales from 0 to infinity. So if there's a day that my team doesn't need to uppercase sentences, this is going to stay at 0. But if the need comes, we can scale with that. We also pay per use. So we don't need to lease a server or a few servers in order to keep this service up. When it's not in use, you just don't pay for it. And The important thing is there is no server management here. It's just running on serverless. And for me, it was an awesome developer experience. So just a few clicks, zero configuration, and we got an application up. This is the essence of serverless for me. We get all of these things with zero effort, and I tell you that I tried to build a few of these things in my last ventures, and it was pretty hard, so it's kind of cool to get it out of the box. So yeah, that was cool, but you know, Slackbot is nice, but can we really use it for actual work? So that's a question that me and my co-founders asked ourselves about 3 years ago when we started Torii. Will serverless work for us? We want to get all of these benefits to everything that we do. We didn't know if to go for it or not, but what we wanted to get is the following. We said that if we could minimize the operations, then we can probably deliver more value to our customers. And if we can do that, we'll have an advantage over the competition, and it will help us win more deals, win more customers, maybe win the market. So it was very appealing. And the last thing, it will help us sleep better at night. So I just had a baby a month after we started the project, so that didn't really happen. But regarding serverless, it works pretty much. So yeah, we decided to go for it and build everything we do on serverless. And here are a few use cases that we use with serverless. So one is for API server. It's very similar to the Slackbot that we just wrote. And it serves all of our clients. We have endpoint agents and we have web applications that talk to it. We have background jobs, which is very much the classic serverless use case. The background jobs can send notifications or parse files or process and compute data in the background. And we also do static content, which is kind of weird to call it serverless, but actually it's like the ultimate serverless application. S3 is like a file storage that you don't have to think about servers, about capacity, about how much disk space is left, and you also pay per use. So for us, this is all under the serverless umbrella. And not everything was smooth, so I'd like to tell you about what we've learned while running it for the last 3 years. So the first thing is once you go with serverless, you get a lot of things out of the box that just works for you. So for deployments, you get all these best practices. All deployments are immutable. Everyone has a permanent version to it. And you can use aliases. What does that mean? It means that you can point your production alias to version 100 while pointing your staging alias to version 101. And then switching that when you find out that version 101 needs to be promoted to production. With this, we get zero downtime deployments. Because whenever a new request comes to a new version, it will just load a new container and serve it from there. The old request just keeps on working on the old container. We also get instant rollbacks. So as someone said today, I don't know if there's anyone who haven't deployed bugs to production, never, ever. But when that happens, it's really easy to just point the alias back to one version before. And we've used it a few times, and that helps us be safe with deploying. So if you look at this, building this yourself is quite hard. But with serverless, you just get it. You don't have to do anything. So the next thing is infrastructure as code. So this is not something that I want in my company, for example, doing infrastructure as code, but because I didn't think about it. But once you go serverless, it comes, the tools are giving it to you. So, and the tools for serverless are mostly for developers, not for DevOps people, not for operation people. So they are very friendly. And they're so friendly that even I can do it. So let's look on an example. So this is from the serverless framework YAML file. And you can see there's a function called handler here. And it will be called in a rate of every 1 minute. And it's really written here in the most simplest way. And you know, if you give it to any developer probably that's working with you, he can edit it with confidence, and it will work for him as well. So you get infrastructure as code, which is simple with the serverless. Okay, security. So everyone is a bit afraid of security when there are new things, and serverless is quite new in the territory. But for us, it helps us get better security. So the first thing is that we don't have to handle all the patching of the systems. So if you find out that the new node version has a vulnerability, you don't have to go and do anything. Usually you will just check, and Amazon has already patched that for you. You don't have to go to your Dockers and make sure that everyone is on the latest version. Another option is to give every function, every Lambda function that you have, its own set of permissions. Instead of giving all the functions the same permissions, you can limit it. So if you have a function that only needs to read from the database, you can just give her that permission. And if someone needs to write files to S3, you can give them that permission. Beyond that, SSH is dead, so we don't have SSH keys for people, and they can't SSH into servers because we don't have any. So there's less attack vectors, and keeps us safe. And lately, we did a SOC 2 certification, which was a lot of fun. But it really helped us because a lot of questions there about how do we manage patch management and permissions and SSH permissions are just solved inherently. So this really helped us, and we really enjoyed it. So everything been like really great about serverless till now, but it also imposed a few limits on us. So here are a few that we ran into. One of them is the 15 minutes maximum runtime. So 15 minutes is a long time, right? But sometimes you need to run things longer if it's long computation or other use cases. We have, for example, a need to sync data from third parties. And this could take days even, or hours or days. So the way that we solved it is very simple. We just use recursive invocations. So when you are running inside a Lambda function, you can ask the environment how much time is left. And if we see there is not enough time to complete the task, we just kick off another one from the same place that we left off. And this also helps us if our Lambdas break for some reason, we can also continue for the same place that we stopped. So this is how we beat the 15 minutes maximum runtime. Another limit is the 30 seconds response time from the API gateway. So using APIs, I think 30 seconds is like crazy. Who wants to get a response after 30 seconds? But sometimes there are file uploads, or if you want to parse large files, that it might take longer. So one of the solutions for that is to use a decoupled invocation. So that means that the API gateway will only be responsible for accepting the requests, and it will kick off a Lambda without delimitation in the background. And the client can poll using a reference number and see when this is finished. So we use that in our system. And the main part is that you don't have any persistent server up. So if you are regular to using WebSockets or doing polling on other resources, it's something you cannot do inside your Lambdas because it's not always up. So there's a service for that. So when you try and use serverless, you will find out that you will need more and more services around it. So Amazon provides services for WebSockets, and you can use their simple queue service for queuing and polling on it. And just know that when you go serverless, you'll probably need more friends with it. Okay, So performance, everybody loves to talk about performance and cold starts. And here's a brief overview of cold starts. So whenever you get a request for your Lambda, the code needs to do a few things. Amazon downloads your code, it starts a new container, it bootstraps the runtime, and it starts your code. And something that is very nice is that after the request is completed and your Lambda is run, this container stays up. We don't know for sure how long it stays up, but it's about 15 minutes. And if there's another request to the same Lambda, the container will be reused. The reuse is what we call a warm start. It just have to do the part of starting your code. So once in a while, when you get more requests, Amazon will have to provision more containers, and the user that had a request will have to get hit by a cold start. This could take from 2 seconds to 10 seconds, depending on the size of your code and the runtime you use. So how can we optimize it a bit? So what we're trying to do is to keep our code small. Also when we're deploying it to Amazon and when it starts to run. So what we found out is that Lambdas are very similar to a website. Yeah? So all of the code needs to be downloaded when you visit the site and evaluated and executed. The same for Lambda. Whenever there's a new request, the container gets the code and evaluates and run it. So we know how to optimize for websites, so we do the same for our code in the Lambda. One option is to bundle it using Webpack. So Webpack is a web bundler. It basically takes all of your code and assets and put them in one file and gets rid of everything you don't use. This is a good solution, but there are some dependencies that are not Webpack safe. They load code from or assets from the disk dynamically, and it can be bundled in a build time. Another option is to remove useless files. So if you look into your Node modules folder, you'll find out that the whole internet is probably there, and you have a lot of README files and test files and example files that are included there. We can go and just remove all of this. We don't need them in our package. So what we do today is we do both. We bundle our own code, which is Webpack safe, and we remove all the files that are not needed from the dependency. Another thing that can be done is to lazy load code. Instead of when the server or your Lambda function starts requiring all of the dependencies, you can just load the code that you need. So if someone goes and tries to request the /users endpoint, you can just load the code that knows how to handle that. You don't need also the code that knows how to parse files. There are some open source projects that try to tackle this. NCC and PKG are basically trying to do the Webpack bundling in a smart way, and they'll produce just one file that you can run. We also solved it and turned it into an open source project called lambdapack, which will bundle and remove all the files you probably don't need. More on performance. So we found out that there's a lot of latency when we use serverless. This is the setup mostly when we set up an API server. There's the internet, there's CloudFront, which is a CDN, and there's the API gateway, and there's the Lambda, and then some database. So each hop might carry with it a 100 millisecond latency. And so if you really need something that is super performant, so at this point serverless might not suit your needs. So for our use cases it works, and Amazon is improving this. Today you can remove the part with the CloudFront and just have what they call a regional API gateway. So all the requests from all the world will go to that place. It will remove one hop, but in the end it might take more time for the end user. Okay, so we're using lambdas and functions because they scale. They scale really well. That means that if you're deploying the Slack bot today and every one of you try to use it and ask all your friends, it will just work without us having to do anything about it. There will be more containers that handle the load. We'll pay for it, but that's what we want. However, what about the rest? So our Slack bot was really simple, but if it had to talk to a database or write code somewhere, this could block our database, and we need to contain it in some way. So for each function, you can declare a concurrency limit, which means that you don't want that Amazon will provision a lot of containers to handle all of the concurrent jobs, and the concurrency will be limited to that. And we had to do it in some places that would just strangle our databases or our Elasticsearch clusters. Okay, this is a question that we asked ourselves: is what's better, like one function or many functions? So if I'm writing an API server, I have a lot of routes. So I can do that every route is its own function. That every time it's called, it has its own container, it has its own security permissions, and it sounds really great. Versus doing just one large one. We call every route will be running the same Lambda function. So what we found out that for API servers, we prefer to go with one large function. So why is that? We have a lot of routes. Some of them are very frequently asked. So if you go and ask for the users in the systems, that might happen a lot. But if you want to change like very specific settings, this might happen like once in a week. In order for all of this to share the same containers and the same Lambda function, doing all the server in one large function is worth it. And we found out it's easier to deploy it and it's easier to test it. Okay, so secrets. So don't store them in GitHub, and especially not in public repositories because they'll find it and kill your and revoke them. So in the world of servers, you probably get them through the environment, and you can use them. You need secrets for your database access and for any other thing that you're using. So Amazon have a nice solution for that. It's called the SSM. You can store them and store their encrypted secrets and environment variables, and you can then request to decrypt it. Our first attempt was to decrypt it at runtime, which means that the Lambda starts, and then it contacts the SSM and decrypts the secrets from there and use them. However, it didn't scale well, and after a while, we found out that there's a limit to how many decryption requests you can send to SSM, and there's no way to lift that limit at this point. So we went for another option, which we bake it during the deployment. So this means that our CI systems know about our secrets, which is a bit less secure, but it's currently the solution we have, and we are looking for Amazon to increase the limit so we can go back to decrypting it at runtime. Okay, let's talk about logging. I think someone talked about it before, but what we've seen is that all the logging SDKs and solutions really want you to have a server. They even have like long instructions about how do you install it on Ubuntu or how you install it on Macs. And you have to have an agent, or they just assume that your server will always be up and never go down. But with serverless, it's a bit different. So has anyone used CloudWatch, the service? Yeah, so who loves their service? Yeah? So I think it has like the worst UI that I've ever seen. So I don't know who built it. It's a great service, but the UI is terrible. So, so what do we do with that? We take our Lambdas output and we send them to CloudWatch logs. And from there, we stream it to another Lambda. And from there, we stream it to PaperTrail. PaperTrail is one of the third parties log aggregation services. And that works pretty well. For one thing, it's outside of the Lambda code. We don't have to integrate any SDKs or introduce any new dependencies. It's really easy to change the target. We can change PaperTrail to Logly. I think it's the same company, I'm not sure. They buy everyone. And if CloudWatch will ever be a better service, then we can just cut this off at the middle. And then we can use PaperTrail to send us alerts and all the things that people have talked about this today. Okay, and last but not least, we're just at the beginning, so it's actively improving. Since we've started, a lot of things have changed and improved in the systems. The cloud providers, I think, see serverless as something that's worth investing in, and there's a lot of new features and improvements all the time. And since most of our infrastructure is on AWS, it keeps improving. That means that we sometimes get gifts without doing anything. We get better security, or we get faster running time, and that's just great without us having to do anything. So a few things that have changed and improved since we started, there are many, so I just wrote here. At the beginning, you could only run it for 30 seconds, the lambdas, then 5 minutes, then 15 minutes. And I'm waiting for them to just remove that limit. Also, we could only use the runtime of Node version 6 and then Node version 8. And today you can use any Node version or any programming language you'd like. I think you can run COBOL there or something. They also improved their performance, and I expect it to be better and better. So after running it for a while, we see all of the advantages that we wanted to get. There are still some challenges. We're looking for the providers to provide solutions. But if you ask me if serverless is the future, then my answer is no. I think it's the present. I think this is the time to use it. So if there's one thing I want you to take from this is the next time you start a project, give serverless a try. Kubernetes, said I won't say it, but you can fall back always back to that. But give serverless a try. You probably won't regret. Great. So I'm Tal, and I'm mostly active on Twitter, so you can catch me there, or you can catch me later today to discuss more about serverless or ask questions. So thank you very much. The question is, how do we test it? Yeah. So we mostly utilize unit tests, which are very simple because it's mainly a function, so we don't need all the infrastructure. And for the other things, we test it on the AWS infrastructure. So if we need to test something, since we use infrastructure for code, it's easy to just deploy another test version and use that. It probably doesn't cost a lot because it will just cost the time that we run the test against.
How many functions do you have running on production? How many different types?
We have about 70, I think, and that will be the last question. We have about 70 different functions that are running, and yeah, one of them is a really big one. It's the API server, and all the rest are very specific. So thank you very much.